How you guys doing? This is Mr. Sugai. We're gonna go over some graphing. Right now we're in section L6.2, page 7, in the second book of algebra. So before we get started, let me clear my video camera here. Okay, I think we're good now. Okay, here we go. My ruler. So determine the symbolic representation for each graph shown below. We got 4 graphs here. Express your answer in slope-intercept form. F of x equals mx plus b. Okay, so what I do first is I find the y-intercept, which is right there. So this point to me looks like 1, 2, 3, 4, 5. Look like 5.5 on the y-axis. Let me just call that y. Just call this x. 1, 2, 3, 4, 5. So 5, 0, 5. So your y-intercept is 5. I'll just say over here b equals 5. Now from there we can plot the slope of the line, or at least find the slope. Okay, let's see. There's a point for sure, and here's a corner point for sure also. I can see that just with my eyes. So from this point to this point, the slope, I'll say like this: rise over run. Slope equals rise over run. Okay, just like that. So the rise here, let's see. From this point here, I go 1, 2, 3. That's my rise. I went 3 units vertically, positive, 3. So the rise is 3. And the run, from this corner, I went 1 unit to the left. So that's 1 unit to the left, which actually is a negative 1. So your slope is actually negative 3. So final slope is negative 3. M equals negative 3. Okay? So now we can write our equation in slope-intercept form. F of x equals m, which is negative 3, x plus the y-intercept, which is b, which we already calculated is 5. Okay, and we're done. Okay, let's take a look at the next problem, problem B. Where's the y-intercept? That's the first thing I look for, right there. And it's convenient because it's a corner point, and I can find the exact value for that. The exact value is 1, 2, 3. Exact coordinate is 0, negative 3. So your B is negative 3. And what is the slope? So from here I go and find another point that I can see that it's an exact number, a whole number that I can use. So we'll use that. So your slope would be rise over run. Rise, from here I go 2 up, and 1, 2, 3, 4 across. 2 up, which is the rise, and the run is 1, 2, 3, 4. So your slope equals 1/2. And now we have enough information to express our our slope-intercept form. Here we go. F of x equals the slope, which is 1/2, 1/2 x minus 3. Over here is a negative slope. Over here is a positive slope. Okay. Okay, let's try some others. Oh, what happened there? Okay. Okay, I think that's good. Okay, for C. Okay, y-intercept for C, I can see that it's right there. Y-intercept. That would be 0.0, comma 3. So the y-intercept is 3. So B equals 3. And what is your slope? Well, I can go 1 unit up and 1 unit across, which gives me slope equals 1 over 1, or just plain 1. We can come up with our function, the slope-intercept form. And because it's 1, I can say 1x, or I can just say x. Okay? You can imagine a 1 in front of there from here. Now, the y-intercept is at 3, so we're going to just add 3. And we're done with that one already. That was pretty quick. Okay. How about this one, the last one on this page, D. You can see it's page 7 there. Okay. Where is the y-intercept? I can see it right there. At 0, -1. Now let's find the slope. Where is a convenient point to go? I'm going to assume that that's an exact meeting in the corner right there on that grid. Exact point there. Your y-intercept, which is the B, equals -1. Your slope equals, well, let's go. Let's see how we get there. From this point on, we go rise 1, 2 units up, and 1, 2, 3. 3 units to the left, which means -3. And we can come up with our function now. Our slope-intercept function is f of x equals the slope, which is -2/3 x minus 1. Okay, and we're done with this page. This is a negative slope. It's sloping downwards from left to right. This one is a positive slope. It's increasing from left to right. You can see that. Okay, moving on. We're going to the next page. Now in this one, we're going to be graphing. This is page 8. I hope you can see this. It says f of x equals -4x plus 1. So let's graph that. There's going to be like 4 lines in this one graph here. Now the grid, I already checked it. It's 10 this way, 10 this way, 10 units up, 10 units down from the origin. Okay. I'm going to call this axis x, this axis y. So f of x equals -4x plus 1 is the first function that we're going to graph. The point is at 1, which is our y-intercept. The slope is -4. Now -4, now over here, look, -4, when the slope is -4, this could mean -4 over 1, or it could also mean 4 over negative 1. Either way, it'll still be the same. Okay, it's just a matter of preference on how you want to figure out the slope, how to draw the slope. So we have our starting point, which is the y-axis. Okay, now the slope is, let's say I can do this, negative 4, 1. Negative 4, 1, 2, 3, 4, because it's the rise, it's the vertical thing, but we're going in a negative direction, and 1, positive. So it's going to be here. That's another point of the function. So we could just draw that graph right there if we wanted to. But before we do that, how about this? Let's try this slope description, which is 4 over negative 1. So we can go 4 up, 1, 2, 3, 4, and negative 1. And we can plot that point right there. We went 4 up, which is the rise. The run, we went 1 to the left, so that's a negative 1. And as you can see, it describes the same function. Okay, it's all part of the same function. These values are part of the same function. So we're going to draw that line there. And this line we're going to call f of x. Okay, now let's try g of x. G of x, see, they already mixed up the order from your standard slope-intercept form function. But we can already see that the negative 3 would be the y-intercept. Here's our y-axis. Negative 3, 1, 2, 3. So the function will cross the y-axis at negative 3. And the slope is negative 2. Now from here, we can go 2 up, 1 across. Why don't I just mark that point? Or I could go from here 2 down, which is negative 2 over 1, and would still be a negative slope of negative 2. And then we can draw our line here. Okay. This would be your g of x. Okay. So as we can see, both of these have negative slopes. The f of x is a lot steeper. It's negative 4x. The g of x is negative 2x. Okay. Now let's see what h of x, how that looks like. Okay. The y-axis is negative 6. Y-intercept is negative 6. So we count on 1, 2, 3, 4, 5, 6. That's your y-intercept. Slope is 1. We can just imagine there's a 1 in front of that x, which means the slope is positive. It goes up 1 unit and 1 unit across. So it's going to be like this, exactly horizontal, diagonal. About so, about like so. Okay. So this one is your h of x. Okay, we're done with h of x. Okay, take a look at k of x. We can see k of x has a y-intercept at 7, 0.0, 7. 1, 2, 3, 4, 5, 6, 7. Let's mark it. Let's count again. 1, 2, 3, 4, 5, 6, 7. Okay. Now the slope is 1/3. It's a fraction. So it's going to be a shallow incline. Okay, that's slight incline. We go 3 up, 1 up and 3 across. Let's try that. 1 up, 3 across. Or it could be 1, 1 up, 3 across. Yeah, okay. Could also be 1 down and 3 across to the negative. So you would have a -1 over a -3 would still give you a 1/3. Okay, let's plot this right here. It would be something like this. Okay, something like that. And this one is k of x. Okay, so we're done with the graphs. How about going over the questions now? So use function stated above in question 2, which is this, to determine the value of the function x equals 15. F of x equals 15. If f of x is 15, if x is 15, it will be 15 way out here, and it would be way down here someplace. We see this f of x is very steep, and if you plot 15 over here, it'll be going down, and where it meets is going to be off the page. So we're going to use the function instead that we know right here, the -4x plus 1, to calculate the function of 15 when x equals 15. Okay, let's do that. F of 15 equals -4 times 15. We're going to substitute 15 in for x plus 1. Okay, so that would be, what, 60? -60 plus 1. And your final answer is going to be f of 15 equals -59. That's it. What about k of 15? We have k of 15. K of 15, if you can see, 15 would be out here, and k would be up here someplace. So it's off our grid here, so we'll just use the function itself because we can calculate it from the function. K of 15, I'm going to substitute 15 in for x, get 1/3, 15 plus 7. Okay, let's simplify. 15 divided by 3 is 5 plus 7. That equals 12. Okay, and we're done. So we're going up, go up 15 over here, about here. Then we're going up 12 units to right here. That'll be about 12. Okay, that seems reasonable. Okay, next one, let's take a look here. H of x equals 60. H of x is this one here. And the formula is, the function looks like this. X minus 6. H of x, oh, okay, this is a little bit different. Sorry, this is a little bit different. H of x equals 60. Okay, let's read the instructions here. Use the function stated above in answer 2 to determine for what value of x the function will have a value of 60. So how are we going to do that? It's h of x equals 60. Now, as we can see, the h of x is equals x minus 6. So we can substitute the function value here in for this h of x here, which is the same thing. So let's do that. I'm going to substitute h of x by x minus 6. H of x is h of x, but because h of x equals negative 6, I'm going to substitute x minus 6 for h of x. Sorry. Okay, here we go. Equals 60. Now we can see that x, add 6 to both sides, it's going to be 66. Okay? Okay, sorry about that. Oh, sorry about that. Let's get that in view. Okay. Okay, g of x is 60. When g of x is equals 60, okay, where is the g of x? Right here. Here's the g of x. It equals negative 3 minus 2x. Okay, let's substitute negative 3 minus 2x for g of x. You see the g of x here and the g of x here is the same g of x. Same function we're talking about. So we can substitute with no problem right there. And we can solve for x now. So when I look at this problem, I look at similar terms here. So I'm going to get rid of this negative 3 first. Okay. If I add 3 to both sides of the equation, I'll end up with negative 2x equals 63. Then I'm going to divide negative 2 to both sides. I'll end up with x equals 63 divided by negative 2. Okay. So this is going to be negative 31.5. Let's see if that's reasonable. Negative 31.5. So here's our g of x. Sorry, this page is kind of large. This is our g of x. When g of x is 60, g of x is 60. Okay. So when this g of, okay, here's the way we're going to look at it. When this line goes up to 60, up here someplace, when this point up here is 60, it's actually off my table almost, practically. But this point here is going to have a value of negative 31. This point over here goes like this. This goes up here, way off the table, and this one here is going to be negative 31. From the origin, it's going to be negative 30, 31 off the table, okay? Also. Anyway. Okay, I hope there is no questions. So, and if you do, you can talk to me either tomorrow or Thursday. Hope everybody got something out of this video. I'm going to end it right now. This is a nice time to end because this one little section is done. It goes from getting a function, a symbolic view of the function. From the graph, we find the slope, we find the y-intercept. And this one, number 2, we go the other way. We have the symbolic form of the function. Now we're graphing the functions. It's a graphical display of the function. Over here, we kind of estimated what is the function value if x is 15 for both of these, for f and k. And for this one, if the function is at 60, what would the x be? And then we solve for x, okay? So any questions you can ask me either either Thursday. Okay, that's it. Sorry about that dog. And I'm going to end the video right now. Thank you very much for watching. Hope you got something out of it. And I'm going to go on to my next video.